Hi again, so welcome to another course where I'm going to teach you a very important approach to solve any laptop or motherboard problem using the power sequence or the power signal sequence. Okay, so let's get started. So before diving into this course, this schematic you're gonna find it in my Patreon page. Okay, you will find all links in the description. So if you understand this approach, you're gonna of course understand how the motherboard is working, how the power rails and signals are generated, and step by step, of course. So you can figure out the problem within any laptop or computer very quickly. So without wasting time, let's get started. First, let's see this square. As you can see, so any square here could be an IC or a circuit or a chipset. Here, for example, we have battery, charger, 3 volt, 5 volt. This is 3 volt, 5 volt circuit. We have the power switch. This is the SIO, the super IO. Of course, before diving into these numbers and these signals, we have first know about the squares and signals in order to understand very clearly, because I know that a lot of beginners follow me in this channel, more than 50%. Okay, so here we have, this is embedded controller or the super IO. Here we have the PCH or the platform control hub. Okay, here we have the CPU power switch, 1.8 volts circuit. Here we have for the RAM DDR. This is basically 0.75 volt, means this is the DDR3, etc. Okay, so let's begin here. We have the charger. The charger basically and the battery. Okay, so the first step we have the power SRC, means the main voltage B plus. Let's say for example 18 volts. Okay, for this kind of laptop. The charger here is not the adapter. This is IC basically. It generates after receiving a voltage input from battery or from adapter. We get power SRC or B plus. Okay. Here, as you can see, we have plus V charger. Okay, this is basically plus V charger. This is the voltage that charge the battery. So when we get B plus, directly the second step is here in the power switch. Here we have power switch, and this is the power switch controller. So number 2, of course, we have this plus 5 volt always that is generated from this circuit, 3 volt, 5 volt circuit, to the switch, to power switch controller. And then, as you can see here, once we press the power switch or on off button, okay, of course, the step number 3, we will get a signal that will be generated directly to this circuit, to 3 volt 5 volt circuit, in order to generate 3.3 volt and 5 volt. Here we have 3.3 volt always on. This is basically enable signal. Do you see? Here we have enable signal. Once the circuit get, of course, the circuit or the 3 volt 5 volt controller that receive this signal, it will then, once it receive this step number 4, this enable signal, it will then generate here 3.3 volt always. We have 3.3 volt always. Okay, number 5. Number 6, it's not plus 5 volt, because the first voltage here generated is 3.3 volts. And then number 6, we have always on, another enable signals. Please, before diving into the course, we'd like to give a huge thank you to the sponsor for this video, PCBWay. PCBWay offers many services ranging from PCB production and assembly to 3D printing and a variety of materials. CNC machining, sheet metals fabrication, injection molding, and more. PCBWay makes it easy to get custom parts for your project And if you don't like to work a lot with a soldering iron, they can even assemble your PCBs for you. That's the PCB way. Now back to the video. Generated from the Super I/O or the embedded controller that will go directly also to the 3V 5V controller. Once it receives the always on enabled, you see here we have enable 1. It will then generate number 7. So after this signal we will get plus 5V always, but we have here another signal. This is system power switch. Normally this signal should be 6, number 6 here, and this one should be number 7. Okay, 6, 7, and then we have 8 plus 5V, and of course we have another voltage plus 15V always, number 9. But this voltage basically we find it just in some computers, and in other computers there is just 3.3V and 5V always. So number 10 we have the SAS on or the suspend on. This is our enable signal. So note that these blue circles or signals are inputs, are coming from this chip, the embedded controller or Super I/O. Do you see? All these blue signals are generated by the Super I/O. So here we have basically a SAS switch, and we have 10 SAS on. Once the circuit receives SAS on as enable signal, it will then generate these two voltages, plus 5V SAS and plus 3.8V SAS, because note that you will find in the laptop many 3.3V and 5V, but it's not the same. We have here, for example, 3.3V always and 5V always, 3.3V, 5V, here also 3.3V, 5V, but it's not the same. In terms of working principle, it's not the same. Those voltages are always present once you connect the charger, but those here are present. Here we call it basically states. We have S5. Those are present is in S5 and those in S3, and you can find also other voltages. We called it, as you can see here, running, plus 5V RAN, 3.3V RAN. Those basically are generated in S0 state once or when the laptop is totally on, is working 100%. You have display, you have everything. We should means running when the laptop is running. We have those voltages especially for CPU and other big chipset. Okay, so please don't confuse. When you find 3.3V somewhere here on the motherboard, it's not 3.3V always. It could be 3.3V for SAS or RAN. Okay, and of course you can get the 3.3V here and the 3.3V here, but you have a missing 3.3V RAN. Okay, you should look for the origin or the source of voltage. That's why I focus always in my channel on understanding the power sequence, the power rails, and how to track the voltage. Because as a technician or engineer, if you understand how to track voltage and the power rail, you can figure out any issue within a motherboard or a laptop very quickly. So we are here in 12. Okay, we have 13, we have RSM reset and or 13, yes, we have 13 RSM reset, and 14 we have SAS power. AC, okay, 15 we have AC present, 16 SIO power button. Very important signal that will help you understand how to solve especially power problems. So guys, because here this basically, as you can see here, this power signal sequence are very important. I will divide it maybe in 3 parts in order to understand it very easily. So This is basically the first part. We're gonna continue tomorrow in the second part. So please, if you want to accelerate learning, you can join me in my Patreon page. All links in the description. Please don't forget to subscribe, share and like the video, because guys, your likes really motivate me to create more videos for you. Thank you very much and see you in the next video.